Howdy, everybody. Hope you're doing well whenever you are. We're here for quest 3 of Everybody Codes. Yesterday was a crazy day. Spent a lot of time on some silly little bugs, but hopefully I won't have issues like that today. Let's hope, and maybe today goes a little bit better. Yeah, I've been enjoying seeing your solutions. Yeah, I'm posting my solutions on Reddit, so if you want to post yours as well and just let me know in the comments, I'll check it out. So I saw some good stuff on how to prevent errors from yesterday, so hopefully I won't fall into those same traps again. Yeah, okay, let's do it. Let's get her done. You are carrying the completed breastplate that you just finished in the forge with the blacksmith. Everyone you pass along the path is drawn to the shiny, finely carved symbols. The knight gets up from the bench and walks over to have a close look at the work as soon as he notices you coming. "This is incredible," he shouts, taking the breastplate in his hands. "How did you achieve this, blacksmith?" The blacksmith smiles with satisfaction but points at you. "It's not just my success, sir. My friend here has something extraordinary in him. Without his calculating abilities, the drawing on the breastplate would never look so accurate." The knight shifts his attention to you, his face expressing wonder and interest. You briefly discuss how you got to the blacksmith's and how curious you are about your origins. "Since you have such an extraordinary talent, maybe you can also help with one problem. In return for this favor, I will take you with me to the garrison, or I will arrange an escort to the Stack Trace Sanctuary, the best place to find answers in the world's books and scrolls." Where are my manners? With all this, I forgot to introduce myself. My name is Sir Mandelbrot. Nice to meet you. Oh, I think someone mentioned that the previous day was a Mandelbrot set. My family has been using engraving patterns for centuries. I'm very curious about how much we will be able to uncover regarding its secrets in the future. Is this the Mandelbrot? Oh, this is just a Mandelbrot. A fractal. Is this just like a fractal page? Okay. You recognize the knight's good intentions, so you agree to help. Also, you have a feeling that these complex numbers could be very useful, but this is something for a completely different story. Epic math duel? How imaginary numbers were invented? Okay. I thought I looked. It didn't look like the previous. Like, I've used complex numbers before. It looked like they weren't quite the same, but I could be wrong. Maybe they were actual complex numbers. Okay. The knight came to the village to get supplies for the army. He has a number of horse-drawn wagons that are full of different wood-sized crates. The carts are already filled with some goods. There are many empty crates still. Excuse me, but it's clear that not all of them will fit on the carts. But the knight has an idea. For as long as possible, he wants to put smaller crates inside bigger ones, and bigger crates inside even bigger ones. Therefore, the crates will take up a lot less space, since only the biggest one will be left from each set. Your knight gives you a list of numbers. Each number represents the size of a single crate. If two crates differ in size, the smaller one can be packed with the larger one. A sequence of crates packed one inside another is called a set. A knight is curious about the largest possible set that can be formed in terms of total size of all the crates forming it. So we're going to be given a list of numbers. Yeah, 10. Wait, what was this 8.5 thing? Do we have decimals, or is that just a... I don't see actual decimals. Like, you can do 10, 8, 5, 3, 2, 1. The sum of the sizes is 29. A few sample sets of the crates can be picked up. For example, the notation means that 10 goes into 8 goes into 5. 10, 8, 5, 31, 10, 8, 5, 2. There are many ways to pack crates. However, out of all the options, the largest set of crates is 29. What is the largest possible set of crates that can be formed from a given list? Okay, so this is just... I mean, I think obviously the most you can use is the unique set of numbers. So we sort dedupe and sum. I mean, that would be my guess. We try it. Okay, we are going to get a isize. Not even going to try it today. It was by comma, right? And then we'll just do input dot sorted iter dot sorted dot dedupe dot sum. We return an isize. We got it. Okay. This may be harder. This is easy because we just know we can just use the best ones, right? So or we want to use all of them. We may have to do some weird pick try things later, but for this one, because it's just like the largest, we just say, okay, we'll just sort them, dedupe them, and then use all of them because that's going to give us the best size. Like what it may say is how many crates can we fit if we only have enough space for part 2 or something like that, and then we'll have to figure that out, right? Okay, let's try part 2. The knight nods, confirming your answer. It seems that it was just a small test of your skills. You are receiving another list with the size of the crates. The packing rules remain the same as before. One of the purchased items has a special mushroom used for brewing potions, which will fit any crate from the received list, but it cannot be packed with anything else and needs a bit of air to survive the journey. That's why it needs to be packed into the smallest possible set of exactly 20 crates. This will allow the larger crates to remain continuously available. To pack the mushroom in exactly 20 crates according to this rule, the following sizes should be used. The total size of this set is 781, and it is the smallest possible set of 20 crates for this list. Pack the mushroom into exactly 20 crates. What is the smallest possible set of crates that can be used for this purpose? So I think we're going to sort take 20 sum. I think it's the same thing. Should we just try that? Oh, I need to decode. Don't forget that. So we'll take 20. Ooh, what doesn't like about that? Oh, like this. 297. What are the odds? Okay. So yeah, this one wasn't much harder. I'm knocking on wood right now. Can you hear it? Hopefully this day doesn't go as bad as the previous day. But remember, we're just sorting the list. And then now that we've got a sorted list, this one says take the smallest 20. So you kind of have to like read the puzzle and say to yourself, what is it asking you? Like, what is it actually asking you? And it's really just saying, give me the smallest 20 values, right? This one was saying, give me the largest subset of unique values, which is the entire subset, right, of unique values. Oh, that's a good point. I actually don't have to. Oh, I think I do need to dedupe, or I think I need to sort in part 1. Because it doesn't work if. Or no, it's not. It's not sort. It's dedupe. Consecutive identical elements. Yeah. So you have to have it sorted if you want to actually dedupe. Okay, part 3. Let's see. Part 3. The mushroom and other goods are loaded onto the cart. The only task left is to pack the empty crates, your notes. Your final task is to pack these crates as efficiently as possible. The rules for packing remains unchanged. There is also no limit on the number of crates that can be packed into one set. The goal is to pack everything into as few sets as possible. Example based on the following notes. The given list can be packed into 3 sets. Here's example. Why would you not do like 89, 88, 84, 82, 65, 50? Oh, because you get 57 here. I don't think this is. Oh, do you know what this is? This is a counter problem. Think about what would cause you to have to create a new set. Notice there's 51 here and here. That means that there's no way for these two things to be in the same thing. 72, 63, 49. Yeah. So notice 49 is in these 3. Because there's a 49, it requires there to be 3 separate things, because you could never pack 49 in all 3 things. So this is actually just a counting problem. We just want to create a counter and return a count of each of the unique numbers, and then return it. I actually wonder if there's a Rust counter. I'm just going to look it up really quick. The way I would normally do it. Oh, there's a counter package. The way I would normally do it is do it with a HashMap. Okay, so let's just do it with HashMap. We'll solve it with HashMap. I did decode part 3, right? So we'll say let counter, let's call it counts equals fx. No, we'll I think what we want we'll just do input.iter dot fold fx hash map default and then we'll do act dot entry I dot or default plus equals 1, and then return act like that. What doesn't like about this? Can it be applied? Cannot borrow. Oh, I need to do this. We're going to return an isize. And so now we just want to find the one that's the largest. So if we do let counts, or let mute counts equals I was going to do a vector and then sort the vector by key, but I can probably just do, what if I just do counts.iter.map? Oh, I think I can do values dot max. Unwrap. Ooh, is that possibly right? How many numbers do we have? Okay, I mean, it is a lot of numbers. Am I doing this right? I'm going to try it. I mean, it doesn't hurt. We can debug it for a minute. We got it. Okay. There you go. So the key intuition was, what would cause you to have to create a new set? And the answer is no one number can be in any set twice. So it doesn't matter how compact you make the sets. Like, say there's these 349s. If none of the other numbers are duplicates, you could put them all in one set, but then you'd still have to put a 49 here and a 49 here. So instead of trying to like put things in items and then creating new items, you can just ask yourself, okay, well, what's going to cause me to create a new set? Now, it would be different if they had asked a question like, can you generate the most equal sets? So say like, oh, I can, you have to create at least 3 sets because of the 49, but can we make them of equal size? Then you may have to do some work to say, oh, where can I put numbers? That one may actually not be hard either. Because, I mean, the way you think about it is you just say, okay, well, I know I have to put 49s in each of these. Go find the other numbers that have anything more than 1 and like put them in the right place in the 49s. And then anything that's left over, I just distribute evenly among the 3. So yeah, that's probably not a good question to ask either, the more that I think about it. So, okay. Today, much easier, right? It felt much easier to me, at least. I think one cool thing about Rust is we're able to do things like this and this. That allows us to solve it relatively easy. Like the solution to the 3 parts is a one-liner, and I guess technically a 5-liner, but like really a 2-liner. If you have a way to alter counts, or to do a counter without using the counter package, I'd be interested with how you do that. In my case, so what happens here is I say, create a default hash map. That's going to be my accumulator, and then give me each isize. And I'm going to try and get that entry from the FX, or from the hash map If I don't, return the default value, which is 0. And then I'm going to dereference it and add 1. So this has the effect of setting it to the current value plus 1 or 0 plus 1. Then I just return the accumulator. And I do that for all the integers. It looks like there was a lot. To get 4888 means you had to have at least 4,888 numbers if they were all the same, which it didn't look like they were. So it was a big list. But, and then this took me a little bit of time to think about, a couple minutes. So I was trying to think about, do I create a vector and then sort by key where I get the value? But then it occurred to me that I can just, for the hash map, I can say, give me the values and then get the max value. And then we just return that. So, okay, not too tough a day. Should we see what other people's solutions look like? Well, maybe let's see what my times were like for the day. Local time. So I think this is like when I started it. So this one went pretty fast. Oh man, that day, so bad. Look at that day. Yikers. It's like, is this saying it took me 9 minutes? I don't think it took me 9 minutes to solve it. I didn't start quite on time. And I also, you know, when I started up, I try and put the little, I mean, I guess I can't point to it, but it's the deepest fit. I put over here the name. So I do have it open for a little bit. Here's what my timers show. Part 1, 6 minutes. Of course, I did do reading, so I don't know. You know, part 2, 3 minutes, and part 2, 3 minutes, and part 3, 7, 8 minutes. Not too bad. I do not think. What do the stats show? I think we're still really early. It's only been open for like a half an hour. Is this saying this person has solved all 3 days? Okay, well that's not unreasonable if you don't use I32s. I didn't sleep well last night thinking about that silly thing. So woke up in a panic, screaming from the bed. I32. No, I didn't. I'm just kidding. What is this? Oh, it has my GitHub link on it. Okay. Oh, I didn't look at the thing. What changed? Do I just get another? Yeah, we got another day. We're getting bigger. Okay. Let's look at some other solutions. C# extremely was expecting a topological sort. Part 3, but it's required computing the highest occurrence of any crate size. Yep, exactly. Distinct sum, distinct order, take 20 sum. These are, I mean, this is essentially what we did, right? Group by C max G dot count. Okay. I mean, I don't know what it looks good to me, but again, this is an easier day, right? At least it felt like it. Handy built-in dedupe method. Yeah, it's not Rust, is it? Oh, it does have dedupe. Okay. Oh, I could have joined them. I could have created a vector. This is what I'm looking at. If I had turned them into a vector, I guess they already are a vector, right? I used iter sorted dedupe sum. It sounds like I could though go like let me input equals input clone input dot sort input dot dedupe then input dot iter dot sum, and I get the same thing. Is that right? Yeah. Okay. Yeah. And instead of cloning, I could pass this as a mute. Using itertools I think is fine though. But I kind of like using itertools because it has stuff, but you know, dedupe also works. Dedupe iter take 20 sum, yeah. I mean, you still iter here too, so. Part 3. Okay, what did they do? Duplicates, sets, Windows 2. Oh, this is an interesting way of counting duplicates. So if you do Windows 2 and they're equal, you know they're the dupe of each other. And then you increase the sets by the number of duplicates you found. Okay, yeah. Again, the goal is to find the duplicates. This may be faster than doing it in a HashMap, because you're doing a single pass of the vector. Mine is turning the vector into a HashMap and then iterating over the values of the HashMap. So this is ON and mine's O N plus M, which is like some subset, you know, the number of duplicate values, or unique, I should say. Very cool. Oh, that's true. You could have done the parts 1 and 2 in a hash set. Very good. Solution. I don't know that it's set in input split sum. Yeah, there you go. So he's this one, they're using a set, right? So they get all the integers, turn them into a set, which uniqueifies them, and then they do the sum. Same thing with part 2, but you sort them first and take 20. Part 3. They did not use counter, which is funny. Python counter is like a joke in competitive programming. It's like, can you use counter? So it looks like they use a hash map with a default value of 0. Okay. How to put create another. I knew you could do string interpolation, but I wasn't aware that you could do a whole bunch of code in the interpolation. That's hilariously cool. Okay. But it's the same thing. Create a set, reduce it by summing. Do a new set, sort it, take 20. I guess this is reverse sorting and take last 20. Counter, find the smallest. Okay. Yeah, I imagine most solutions will be the same. I'd definitely be interested if you did it a different way. Show me how you did it, and we'll take a look. Otherwise, yeah, I'll post my solution here. And you can post yours too. Let me know if you posted them here, and we'll check them out just to see what they look like. And if I find anything like crazy, especially as the later days come and I'm like missing something, I can show them to you. Like, for example, let me find what's the best way to do this? Open link in new tab. Solution 2. This was a commenter, and here's how they got around the molasine. I don't know if you remember, I had a crazy problem with molasine where I was setting self x equal to this and then self y equal to this, but I had already updated self x. So I think I had mentioned this before with other problems. You can do like a plus b equals b plus a or whatever to swap. In this case, though, what you're doing, and the reason why it works is this part of it, the right hand side of it, is evaluated first, and then these values are set to those evaluated values. So that allows you to do something like this, where I think if you look at mine, I create 2 temporary values. I mean, underneath the hood, it'd be interesting to see. It may be the same, but this is a good thing to like keep in mind when you see this type of stuff. They also do it a lot with like, you'll see destructuring a lot in places. I think I've done that before too, right? So just recognizing like what that's happening is right here. Anyway, this was a great solution to my problem. So anyway, that's all to say. Post your stuff and I'll look at it. If it's anything crazy cool, we'll definitely take some time in like the intro of one of the videos to look at it. Especially if it's like algorithmically different, like I can say, oh, clearly I could do this a better way. I'll definitely check that out. So there you go. Thanks everybody. Have a great day, and we'll talk to you next time. Bye everybody.